Hello guys, welcome to the Fundamentals of Aerospace Engineering lecture. So today we'll see the topic on wing structures. This is Professor Nehru, Department of Aerospace Engineering, SNS College of Technology. So in last few classes we have discussed about the aircraft components, material used in airframe construction, and examples of material used in airframe construction, the functions of aircraft structures, and the different types of fuselage structure. And now we'll see the wing structure. And many high wing airplanes have extended brasses or wing studs which transmit the flight and the landing loads through the studs to the main fuselage structure. Since the wing studs are usually attached approximately halfway out on the wings, these types of wing structure is called as semi-cantilever. A few high wing and most low wing airplanes have a full cantilever wing design to carry the loads without external struts. The principal structural parts of the wings are spar, ribs, and stingers. These are reinforced by trusses, high section beams, tubings, or other devices, which including the skins. The wing rims determine the shapes and thickness of wings. We call it as aerofoil. So the wing is made up of the aerofoil, cut section. So wing structure of an airplane consists of stingers, ailerons, wing flaps, skin, spar. Spar we have two types, front spar and rear spar, fuel tank and ribs. Also skin is jointed by rivets. So spar is the main structural element which is attached with the fuselage, which is carrying the major compression and tension load of the wing structure. So wing structure in the most modern airplane, the fuel tanks either or an integral parts of wing structure or consist of flexibility containing mounted inside of wings attached to rear or tailing edges of wings. The two types of control surfaces refer to ailerons and flaps. The aileron extended from the about the midpoint of the each wing outwards towards the tip and move it opposite direction to create aerodynamic forces which cause the airplane to roll either in a clockwise or in the anti-clockwise. The flap extended outwards from the fuselage to near the midpoint of each wing. The flaps are normally flush with the wings surfaces during rushing cruising flight. When the extended the flap from the wing, which moves simultaneously towards in both sides, which increasing the lift forces of the wing to take off and the landing case. So coming to the cut section view of the skeleton view of wing structure of an airplane, see here we have the red color indicates the ribs and this line indicates the skin and fuel tank is placed near to the fuselage and wing tips we have the yellow color stingers and the control surface aileron, spar and wing flaps. Flap is attached near to the fuselage which increasing the lift producing device. And the different types of wings are based on the design. The tapered leading edge, which is called straight tailing edge wings, tapered leading and the tailing edge, delta wing, sweep back wing, straight landing and tailing edges wing, straight leading edge and tapered leading edge wing. So here are the different types of wing based on the operation, whereas trainer aircraft, fighter aircraft, or commercial aircraft, or the cargo aircraft, based on the load carrying and operational speed, this wing can be used. Here we can see the three different types of the aircraft and their wing configuration. The set of wings that may be swept back and then return to its original position during flight. Swept back wing, we can Airbus 380. This is a sweep back wing type. And this is a Toronto F3 is a variable sweeping wing where during the flight in the less than Mach number 1, it is a straight wing. And when it goes to high speed or in the Mach number more than 1 and a supersonic speed, it will retract and act as a swept back wing. Whereas in concact aircraft, this wing is delta wing, which is in high speed supersonic aircraft. So based on the position, we have low wing type, high wing type, and mid wing type. And the shape, we have straight wing and gull wing, inverted gull, mid wing, and dihedral anhedral. These are the various wing shapes and position. Based on this wing position, we categorizing the wing configuration. So coming to the empennage structure, the correct name of the tail section of an airplane is called empennage. The empennage includes the entire tail group consisting of fixed surface such as vertical stabilizer and horizontal stabilizer. The movable surface includes the rudder, elevator, and one or more trim tabs, which is located in the horizontal and vertical stabilizer. The second type of empennage design does not require an elevator. Instead, it incorporates one pieces of horizontal stabilizer that pivots from a central hinge point. This type of design is called as stabilizer, and it moves using the control sticks just as you would use the elevator. Coming to the empennage structure, the rudder is attached to the back of the vertical stabilizer. During flight, it is used to move the airplane nose left or right, and the rudder is used in the combination with the ailerons for turns during flight. So that we call it as coordinate turns or coordinate coupling. This elevator, which is attached to the back of the horizontal stabilizer, is used to move the nose of the airplane up or downward during flight condition. Trim tabs are all small movable portion of the tailing edge of the control surfaces. These movable trim tabs, which are controlled from the cockpit, reduces the control pressures. Trim tabs may be installed on the aileron, the rudder, or elevator. So this picture shows the empennage of an airplane, which is having horizontal stabilizer and vertical stabilizer, and the other control surfaces like rudder, trim tab, and elevator located in horizontal and vertical stabilizer. So empennage structures of an airplane is having the skin, brass, rib grinders, clips, form sheets, hinges, sheet bibs, and the both horizontal and vertical stabilizer. So empennage structures of airplane, we can see from this picture, spar is located both horizontal and vertical stabilizer. Stringer also located both horizontal and vertical stabilizer. Stabilizer race called this control surfaces covered by skin surface. So aircraft tail types, here we have different types of tail types. That's empennage type. Dorsal fin we have at the rudder. Ventral fins we have in the horizontal controls. Standard tail, twin tail, T-tail, and butterfly type tails are there in the airplane or aircraft tail types. Aircraft tail types, these are the conventional type T-tail and V-tail, triple tail, dust tail, inverted V-tail, inverted Y-tail, twin tail, boom tail, high boom tail, multiple plane tail. These are all the tail designs of airplane. So, for example, we can see this standard aircraft. We have the V tail and T tail. We have the in the Antova AN 14800, the aircraft. We have this T tail and Antova 22 model. We have the fin tail, and this train aircraft we have the V tail or V butterfly tail model. So this is the categorizing and types of empennage or tails of different types of aircraft. So here we are concluding the empennage part. Next class we'll see the other uh, the basic aerodynamics of aircraft. Thank you.